Evaluate the limit at x go to 0 on the right-hand side of the hyperbolic cotangent of x. First, we would need to rewrite it in terms of the exponential ex and e to the negative x. This is the limit at x go to 0 from the right-hand side. And by the definition, the hyperbolic cotangent of x is e to the x plus e to the negative x over e to the x minus e to the negative x. This is the hyperbolic cosine of x over the hyperbolic sine of x. To find the limit at x go to 0 on the right-hand side, we will use the same trick that we've been doing, and that is we would divide by e to the x, e to the x, e to the x, e to the x. What we're doing here is we multiply 1 over e to the x on the top and 1 over e to the x at the bottom. This is a well-chosen one, so we are not changing the limit at all. But this helps us clean up the expression just a little bit. E to the x over e to the x is 1 plus e to the negative x over e to the x is e to the negative x minus x, which is e to the negative 2x. And so we have e to the negative 2x over e to the x over e to the x is 1 minus e to the negative 2x. As x go to 0 from the right-hand side, this is the limit at x go to 0 from the right-hand side, 1 plus 1 over e to the 2x over 1 minus 1 over e to the 2x. At x go to 0, we would have e to the 0 is 1, and so 1 plus 1 is 2 in the numerator. And at x go to 0 on the right, the denominator is 1 minus. We know that this term also goes to 0, but we want to know whether this is more than 1 or less than 1. This is what the graph of e to the 2x looks like. And so e to the negative 2x, which is the reciprocal 1 over e to the 2x, looks like this. Just right on the right-hand side of 0, 1 over e to the 2x is a little bit below 1. And so this number is smaller than 1. Think of this as 0.999999, which is the limiting value. And so we have 2 over a very small but positive number. And so this is positive infinity. What this shows us is that if we were to sketch the graph of the hyperbolic cotangent of x, we will get a vertical asymptote at x equals 0.